Well, first of all, thank you everybody for coming. There's going to be a bit of a whirlwind overview tour of Nix, NixOS, and the Nix ecosystem, and Sane system management. First of all, there's a bit of an overview of what we're going to do. I'll tell you a little bit about myself, but it's really not important. We'll kind of go through the state of the system. So we're going to compare Nix to the existing mainstream solutions that probably most of us have on our computers right now. We'll do a bit of a dreamland tour of what if we could do better. And then we'll see if Nix fulfills those criteria before we jump into what's Nix packages, what's NixOS. There are a lot of Nixy things that can be a bit confusing, and so we'll go through them one by one. If we have enough time, I'll go through some encore bits with how to build a Python program with Nix and how to build a Haskell application with Nix. We'll see if we can get to that. All right, so my name is Tim Steinbach, senior software developer. Okay, are we good now? Yeah. A senior software developer at a company called eSentire. We're out of Ontario, Canada. Specifically, I'm on a team called Advanced Threat Analytics. So basically what we do is we try to employ machine learning and AI to build data pipelines that try to detect unknown concerns, vulnerabilities, threat actors, etc. We've actually, I think just last year, come across a couple of zero-day vulnerabilities that we reported to software vendors just by analyzing user behavior and software behavior. Anyways, here's my social, if anybody's interested. Let's get started. The state of the system. Windows and Mac OS. I don't know what camp everybody's in. I'm trying to gauge. Yeah, exactly. So from my perspective, Windows and Mac OS are effectively the same. You have to trust what you're getting. It's largely closed source. If you're updating in place. You have global libraries everywhere, so if you have an in-place update of a library, it changes for everybody and you don't really have a choice. And at the end of the day, your entire installation and setup process that you go through when you buy a new MacBook or whatever is effectively manual. You get a very bare bones system, and then you got to spend probably a day's worth of time to get it to a state where you're comfortable with working with it. All right. Linux, kind of similar, not as much closed source. There is closed source stuff, but we like to think that Linux is the open source alternative to the former two. But a lot of distros have the same exact problems that come with in-place upgrades, global libraries that are shared, and again, the installation is very much a manual process. You get a new computer. It'll take some time until you're really up and running. All right. Here's my favorite part, actually, of this entire presentation. So I went digging through the 3 OSs and tried to figure out where would application keep configuration and state and such things. I'm not a Windows user and I'm not a Mac user, so I had to kind of dig into my colleagues at work a little bit. This is apparently where typically Windows configuration lives. What these folders mean, or how you decide what's in the registry, what's in a folder. Apparently one of those folders, the very bottom one here, relatively recently also got renamed. But it's supposed to be the same thing, so there's like a fake symboling thing going on where you can actually address it via both of these paths. Regardless, when I look at this, I don't know what's inside these folders. And you have to think beyond that, where a lot of application developers probably also don't know what these are for, so they're just going to invent a new one inside their application folder. So the point is, if I have a new Windows computer and I want to configure everything, all my application, the way that I want it to be, I'm going to have to look through all of these things somehow, whether I write a script that sets things up or I have some sort of zip file that I bring over. I'm going to have to deal with all of these locations. macros, these are the three typical ones. But there are also, a lot of locations that application developers just decide are now places for configuration. You kind of have the same thing going on. It's really up to the application developer to follow some sort of rule, and to be honest, a lot of applications don't. Linux, and there are more of these. On all three systems, there are more of these paths. The typical ones, some of these may or may not even exist on your system. Inside your home, a lot of applications just dump stuff there. You have the convention, go into .config. Some applications put their stuff there. But really, once again, you don't have that one singular place where here's my configuration. It's usually all over your system. And we haven't even talked about what's actually inside these folders, right? Not only do you have to deal with all these places where things could be, but what do they look like? I'm sure we've all seen XML configurations. JSON's pretty popular for just about anything. So configuration is one of those things. I've seen SQLite databases that applications just dump their config into. Mac has these plist files. Sometimes it's something very simple, like a Java properties file. It's just a key value pair. Or what if an application comes along and just has its own binary format of some sort? They just serialize an object to disk and they're good. There's no way, if I were to take a computer today and buy a new one, to migrate all my stuff over in an easy fashion. This is taken straight from the Ubuntu manual. So this is what a typical installation of Ubuntu looks like. You get like you have an overview, you get your system requirements. So then you actually boot from the flash drive. You get a screen that actually says prepare to install Ubuntu. I personally don't know what that even means. It's like mentally getting ready to put this onto your computer. I don't know. I also didn't dig into it, so it might have some bootstrap stuff that goes on. I don't know. You allocate your drive space, you begin the installation, select your location, your login details, etc. Sounds pretty standard, right? I think we've all gone through that kind of stuff. Then in the background, an installation runs while it's kind of promoting featured packages to you, and then the installation is complete. Sounds simple enough, even though some of these steps could probably be reduced. My problem with this is I'm way out from being done at this point, right? Now I have a bare bones system. I still need to install all my packages. I need to bring my configuration that lives in 8 different folders in 12 different file formats. And cutesy things like I want a wallpaper, right? I know what my wallpaper looks like, but now I gotta find the JPEG somewhere, put it somewhere else, set it as my background. Ubuntu would really like you to do that through some UI, and it just takes time. I'm personally not very happy with that. So what if, right? What if all that configuration junk, all of it, was in one single place? I could just go there, change something, bam, be done with it. What if all those applications that I need could be configured through that one place? That would also be pretty cool. What if all those applications then brought their own dependencies? So I don't need those global libraries, right? If I update global libraries on an Ubuntu system, I'm not guaranteed that some other application still continues to function. What if I could reinstall the computer with everything, with my wallpaper, in say 10 minutes? Go from scratch, from a blank computer in 10 minutes to a setup that has my user, all my applications, that has everything, all right? What if most of the software was built from source with a binary cache? Now we have this in some systems, don't get me wrong, this is still my what if spiel. Some of this is actually possible today. And then the last bit, what if I had bitwise reproducibility of the entire system? This is where it gets really interesting. We can talk about software reproducibility, and everybody kind of understands something else. But if I say bitwise reproducibility, I'm going to take 2 computers on 2 different days, and I want them to compile an application and spit out the same exact bits. And turns out that's actually a pretty hard problem to solve. When you think about, application that at the bottom says copyright current date, you're done. I can't bitwise reproduce that, right? Because that date is going to change on the day that I compile it. So what if I had all of these things, right? Feels like it would be pretty cool. And in my one place where I have configuration, not only do I want that to be one place, I want it to be one single file. Everything in there. I want my kernel options to be in there. I want to have what services I want to run, how they're configured. I want to configure on what interval my system updates are pulled in, what channel they're pulled from, etc. From where I'm standing, that sounds way better than the Forma 3 systems we just looked at. And back to my dependencies a little bit. I keep mentioning global libraries it's kind of my thing. I don't like them. So what if I had all my applications linked to versions that are guaranteed to work? All right. So if I have some application and it says, oh, I want OpenSSL. Does it work with every possible OpenSSL version that has ever existed? Well, then you get package manager or some sort of build tool, and it says, oh, I want OpenSSL, I don't know what the current version is, 110G or whatever, right? They have some version. That's good. That's the first step. But what if I want that OpenSSL with that version to be compiled by a certain compiler of a certain version? Now I'm lost, right? Now with OpenSSL, it may or may not be important that it's actually, the transitive compilation is with a certain compiler, but in some cases that may be important. And in order to get to my bitwise reproducibility, that's definitely important. So the way I call it is basically have versions that are known to work. Right? It doesn't seem so unreasonable to have a piece of software that depends on a piece of software that is guaranteed to work with me, because that's what I've tested with. In order to cut back on some of the clutter, though, you're gonna have to share but not overshare. So what I mean by that is, well, what I could just do is I could say, well, my application is going to be this giant bin of dependencies now, and I'm going to give you, every 200 kilobyte application now brings a 2 gig bucket of dependencies. My hard drive would be full very quickly. So what you want to do is you want to have a mechanism that can say, well, these two applications both need OpenSSL, they both need the same version, they both need it compiled with the same compiler, etc., all the way down, so that I'm guaranteed that these two are actually identical. Then I can obviously share them because I've just proven that they're identical. I would really like that. So in comes Nix, and Nix kind of promises to solve at least some of these problems. It's taken straight from the Nix website. It's a package manager that makes package management reliable and reproducible. Sounds good already. They even mentioned on their website that it's reproducible, so I was hooked right there. So some of the things it claims to have are atomic upgrades. What does that mean? If I say I want to upgrade, say, a package, and somewhere in the middle something dies while, downloading a dependency or building something or, linking stuff together, whatever happens, something dies midway. I don't want that broken update, right? I want to just sit on my old version because clearly my update to the new one didn't work. What if the update did work, but I'm not happy with it? Oh no, I updated some UI application and they decided to redesign the UX and I can't find my buttons anymore, so I don't want it. I want to be able to just say, well, roll back. I want the old one back. And I want the old one back with all of its dependencies to make sure that things still work. Nix can do that. On top of that, I'm usually not very happy if I have to install an application and, I work in cybersecurity, so maybe it's a pen testing tool. I don't want to install it for everybody that ever uses my computer. let alone a server that I'm trying something on, right? So maybe I want to install a package just into my user environment, so nobody else has direct access to it. I can do that with Nix. It can just install right into your user environment, give you your user-specific path of applications defined. I can even go so far and have side-by-side installation of different versions of the same application. So if I want to compare, you know, I don't know, I have some Python script and I'd like to run it with Python 2.7 and 3 because, you know, I'm going through that painful migration. I need to compare and I need to have both at the same time. Usually the workaround is that a distribution will rename the Python command, and now you have Python 2 and Python 3, or whatever they do. And that's fine. But what if it's not such a typical example, right? What if I want Python 3.5 and 3.7? Now they're both called Python 3, so now they're going to collide, and you know, depending on my path setup, I'm only ever going to get one of those. Let alone the fact that I need some sort of extra tool, you know, to let me swap environments all the time so that I can even get to the two different binaries. And finally, Nix has pretty good support for macOS and even Windows. I don't know why this keeps happening. Anyways, let's wait until the slide is back, please. Very good. My computer never went to sleep. I don't know what this is doing. Anyways, claims to have pretty good support for macOS and Windows beyond Linux. Obviously, you know, a lot of people involved in this project are Linux users, so really Linux has the best support. But macOS is really good. Windows, I'm actually not so sure. I've never seen it in person, but I hear that, especially with the what is it called, the Linux subsystem that Windows has now, it's supposed to be fairly workable. So let's get into a couple examples. This, for example, is me installing GHC, two different GHC versions, just into my user environment, right? I can just say, hey, I want GHC 822, and what will happen is it'll do all the path setting up, and now I'll have access to GHC. Pretty standard, right? Then I'll go and I'll install 864. And again, it'll just, you know, bend my path setup and install a bunch of things. And now I have 864. What actually happened here is when I just say, so these readling-e resolve symlinks. Okay, it basically says, okay, if I just typed in which is virtually the same as saying type-p. Sorry, I should have explained that. It's the same thing, if you're familiar with which. It'll just give you this, the bottom line. But that's just a symlink to the actual version. So what happened here is, I didn't really install GHC into my user environment. What happened is, I installed it somewhere on my drive, and I got a symlink to that into my user environment, which allows me to also switch package versions really, really quickly, because all it's going to do is swap the symlink back, right? And so if I ran the first command again, it would literally just delete a couple symlinks, create a couple symlinks, and I'd be done with that. Let's look at rolling back updates. So here I am, currently have GHC, OpenJDK 11, and unzip. Don't ask me why those were the three packages I had, whatever. So I can again see if I do an ls on what my Java is, it'll point at Java 11. If I then tell Nix to just roll back to whatever the last generation is. So every time you run updates, it creates something called a generation. That is all that package set that you currently have. So I can roll back, and once again, it's just a bunch of symlinks that get bent back and forth. And if I then ask what I have installed in my user environment right now, suddenly Java 8 is back. Because guess what? Last time I ran update, it replaced Java 8 with Java 11. I have a question back there, yes?
Is all of this persistent in the sense that when I install things with NixShell, this is into the user environment, right?
So the symlinks are persistent in your user environment.
Right. So if I reboot and I boot back in, I'll still have access to these?
Absolutely, absolutely. So I'll go into that a little bit further now that I have the question. So you see a path here that's called, so Neko is my user obviously, and then there's a folder Nix profile, and that is basically where all the symlinks kind of end up, and that's where your path actually points to. The software is actually installed in something called the Nix store. So the Nix store is kind of it's a special kind of beast, which is generally a read-only file system. So you can't just go in there and change things. You have to go through the Nix tooling to add things to the Nix store, get things garbage collected, etc. So the actual software doesn't live in my user environment. So if another user decided to install Java 8, they would get a symlink to that same exact installation, right? So I'm not wasting all my drive space by, I don't know, putting all the software into my home folder. Does that sufficiently answer your question?
Yeah.
Perfect. More or less the same happens here with your dependencies. So I said I don't like global libraries, right? And in this case, it's kind of like bring your own dependencies, but not. Because I said, you want to share, but don't overshare. So if I look at Java, and I just picked the first 5 because apparently Java has a crap ton of libraries that it links to. These are all linked against direct versions, right? So very specifically versioned libraries. And that basically guarantees that my Java installation actually works, right? If I looked at this on, say, an Ubuntu, and I might be wrong because I haven't done it, but I imagine that's how it works. It'll just point at whatever your system currently has as, say, a libdl.so. And if you rip that library out, it won't find it anymore. If you replace it with an empty file, it'll just complain that the library is invalid, etc. So you're not actually sure on such systems that your Java is continuing to work. You can even do that in a tree shape. So I had to cut this off quite a bit because once you go into tree, things get kind of crazy. So this is basically me looking at what dependencies does my GHC have. And we're going to see some of the share but don't overshare in here. We're going to spot glibc, for example, a bunch of times. Because GHC needs glibc. But it also needs other dependencies, which in turn need glibc. And you'll notice that not only the versions, but even the hashes are identical. And so we're sharing literally the same version of the library here. What could happen, and it would be rather unusual, but in theory what could happen is that for whatever reason, GMP decides, oh, I want a different glibc, and then it would bring that along, whereas everybody else is still sharing the same library. What would not happen is if GMP says, I want a different glibc, and the system just goes, well, too bad I only got the one. All right. NixShell. So now we've kind of discussed the package manager that is Nix. Okay. There's a tool built in that's called NixShell that, well, there's not really much to explain. It literally gives you a shell with a certain setup. So I can say I want to open a NixShell with a package without actually installing the package into my user environment or my system environment. Yes, it will live in my Nix store again because everything lives there. But if I exit out of this shell, Kafka Cat won't exist anymore. It only exists on my path, readily accessible, while I'm in this shell. Okay, so I can easily try things out, and I see a question back there. Sorry.
That almost reminds me of like Python virtual env, but for like bash.
In a way, except not constrained to Python.
Right.
I could actually emulate virtual env with NixShell, right? But yes, the concept is very similar, where yes, the software lives on your disk. No, you can't access it through your path, except when you open a shell, you know, have it available temporarily. You do your thing, and then you close it again. One of the things I like to do, for example, is a lot of the software like KafkaCat, that's where this example came from, that I use every now and then, I basically just make an alias in my zshell RC, where I say, well, KafkaCat just points at a NixShell that is KafkaCat, right? And then if it got garbage collected, it'll pull it back, and if it's there, it's there. But it's not cluttering up my environment, right? I don't need KafkaCat all the time, I just need it when I need it. All right, so now the question is, it's all great. Where do these packages even come from, right? They don't just magically appear in the Nix package manager. And the answer is basically, well, let's say basically, because there's more to it, as there usually is, one GitHub repo, okay? And this GitHub repo currently has, you know, this changes on almost an hourly basis. So roughly, let's say roughly 180,000 commits. There's over 2,000 people that have contributed to it. According to the NixOS website, we have over 50,000 packages available. Most of them are reasonably up to date. Not all of them, and if you find one that's not, you're welcome to send a PR. We've closed about 50,000 pull requests. So now you're going to notice a discrepancy. How do you have more than 50,000 packages, but only about 50,000 pull requests? And that is that a lot of people with commit access will just continue on a periodic basis, just updating sets of packages. So there are certain people that have taken on the responsibility of keeping Haskell-related packages up to date. There are certain people that keep the Linux kernel up to date, etc. Right? So you have these pockets of people within Nix packages that, you know, a lot of times in their day job work with Haskell. So why not keep this up to date, right? The whole repo itself is MIT licensed. I don't know if that makes any difference to anybody. Just thought I'd mention it. Then there's this thing, and I don't know how much attention you want to pay to this. So there's an algorithm that was published that tried to analyze how reputable a GitHub repo is. They took a whole lot of factors into play. If there is a company behind it, how many people are involved, how much traction does the repo have, etc. They found that these are the top 5 most reputable GitHub repositories. And I was actually surprised that Nix packages was one of them. And when I tried to, that's why I pulled up the paper, and yeah, it makes sense. There's a lot going on in Nix packages. There are a lot of people involved. And so they found that that is one of the factors that means this repo must be reputable, because it's not just one person going rogue, creating tens of thousands of commits. It's actually a community that's valuable to GitHub. All right. Of course, you don't always have to build from source. You can if you want, but you don't have to. So everything in Nix packages, or almost everything, will be built by something called Hydra. And unfortunately, there are tons of software packages called Hydra. This is our Hydra. It's basically a CI tool. So it will take Nix packages and try to build them all. Populate a binary cache that the average user can then just pull binary artifacts from, rather than building from source. Everything, as we saw, everything is attached with versions and hashes. So if you don't trust what Hydra does, you're welcome not to use it, or you can run your own Hydra, etc. But there is a binary cache available. There are actually various job sets that run on Hydra, and a job set is more or less a Git branch to some degree. So what happens is you have the master branch, and we consider it generally unstable, right? And then you have normal users of a Linux distro. They don't want all the newest stuff all the time. So we also have stable branches that get built separately. So if you'd rather use like an LTS, you can do that as well. All right. NixOS. I've been talking. Oh, sorry. Yeah.
Is it unstable because when somebody is creating a package with like the Nix expression language or whatever, stable ranches, you're kind of guaranteed that the packages that exist in this stable ranch, like 1903 or whatever, that you're guaranteed that these are gonna, you're most likely not gonna have a problem with that, right?
Most likely, yes. Yes. And obviously refactorings of Nix internals or other things happen on the master branch. So sometimes there are days where the master branch literally doesn't work. If you try to build your NixOS on top of the master branch, it just won't. Right? So if you're using this on a day-to-day basis, you might want to go with the stable, because every now and then there's just shit happens. Let's talk about NixOS a little bit more. I've kind of mentioned it already. It's basically a Linux distribution that embodies all of what Nix promises. So everything is run through the Nix package manager. All the packages from the kernel and your grub through OpenSSH, everything comes from Nix packages. And because of that, the entire system now has the benefits of rollbacks, of atomic upgrades, all of that, right? Just out of the box, it just happens. I don't have a good way of showing you. Imagine you have, everybody kind of knows what grub looks like with those, boot menu entries and such. And generally you have like boot into my system or boot into the console, and then you have boot into the console in safe mode because everything's fucked up, so I need to fix something, right? What happens with NixOS, basically every time you upgrade your system, you get one of those generations, and it will pop into your grub. So if you upgrade your system and you boot into the new version, and for whatever reason, things don't work anymore. I don't know, the kernel dropped support for your hardware, which rarely ever happens, but in theory it could. So you try to boot in, and the init just tells you, no, I can't boot what you're trying to do. You can literally just hit the off button, hit the on button, and in your grub menu, just go down one, and you'll get your old generation back with your old kernel, with your old packages, with your old everything, and it'll work. That's it, right? So if an upgrade isn't good for you, if you don't like it, if it breaks, whatever, just reboot and pick a different version, and you're usually good to go again. Reproducibility, oh, I'm sorry. This is a website that I don't actually know who put it up. I want to say Graham did. How reproducible is the NixOS ISO currently? So you have to imagine this is, an ISO with the bare bones to get just about anybody started. And when I took this screenshot, I don't know what today's number is, 98.82% bit reproducible. I'm not just talking reproducible in some, wishy-washy sense. We're talking about bit reproducibility. There's actually a section underneath on the website, tells you a whole bunch of info of why some other packages aren't reproducible, and I guarantee you there are people working on getting this to 100% right now. And that's pretty impressive. If you imagine that's a full ISO that's almost 99% bit reproducible, that's quite the achievement. And this is what my installation procedure looks like. Format, well, gdisk is just, you make your partitions. I'm a bit lazy, so I generally just have one partition and I make it extended 4, and then I'm good to run. You mount the partition, and then you can do one of two things. I have a giant configuration file on my GitHub that I literally just curl in. Or if you're starting new, you can ask NixOS to generate a config, and depending on what your system looks like, it'll generate a config for your hardware and for your setup, for the partitions you just made. And then you say NixOS install. That's it. Everything will now happen. So if I curl in my configuration, and my configuration has, like I said, my kernel has all the tweaks, it has my users, it has my wallpaper, it'll all be set up. And because I'm pulling from binary cache, the time this takes is effectively limited by your internet connection. There's not much else that happens here. And that's it. Now I'm good to go, right? I can go from a new computer to the same thing that I have sitting on my old computer right there, I want to say in 10 minutes. 15. What does the configuration look like? I said I can configure pretty much anything in that one configuration file. And this is what it would look like. So there is something called, so this is where it gets a little bit confusing. We have Nix the package manager. We also have Nix the language. These configurations are written in Nix the language, and it's pretty straightforward. And I can literally change anything I want. If I want kernel parameters, if I want to turn my U2F support on and off, if I want to turn, my Docker daemon on and off. So me saying Docker enable true will literally cause the system to install Docker, to configure Docker with whatever options I gave it here. Yes, please.
So are these different from Mac and Linux, or would you share a file between them?
Oh, that's a very good question. So this configuration in particular is specific to NixOS. Right? Obviously on a Mac, you wouldn't configure your kernel in Nix, because there it's just the package manager. What I'm showing here is a configuration for NixOS.
Can you compose it, like certain things you would share, certain, like say you want Apache Spark on both, can you compose configuration files? Can you share Spark on both?
I want to say yes, but I'm not terribly familiar with Nix on the Mac. So I don't know that I can sufficiently answer your question.
What does Nix do on the Mac? Is it like homebrew or something?
Yeah, it's very similar to Homebrew, or I think there's Mac ports as well. The idea is very similar. You bring in foreign packages through a package manager, and the package manager takes care of setting everything up. The difference is that Homebrew has a world writable folder that it puts things into. Nix has a read-only file system, is reproducible, has those upgrade paths, and it's the same idea with where Nix is. I'm going to go out there and say is a way better tool than Homebrew.
So the main difference is that your packages are globally version at any given time. Is the main.
Yes. Yeah, I would say so. Okay, was that okay?
One other question.
Yeah, absolutely.
A number of slides ago, you installed GHC twice. What determines what is the, and I assume that it would be set up such that if you just had a raw GHCI on the terminal and boot some version, what determines what is like the actually on your path? Is it just the order that you installed it, or is it going to be version based?
It is the order in which you installed it. So if you were to say install GHC 864 and then 822, now your GHC would be 822. Gotcha. And if you say update, it would actually go back to the newer version, of course.
Okay, so the updates are version.
The update is versioned, but your currently accessible, symlink on your path is whatever you installed last. This is part of the default set of packages that I install in NixOS. So not only do I configure my system and my system packages, if I just have generic packages that I want to be there, I can say that as well. I can say I want Git, right? I use Git all the time, so I want it to be there. Again, all of this is in one single file. And here's one more cool feature, and I actually use this quite a bit, especially if I'm tinkering around with the Nix repo itself. One of the things you can say is rebuild, but build me a VM. So generally you would say, well, rebuild my system, and then you would decide, do you want to change all the symlinks in place? You can actually do that on a live system. It'll just change all the symlinks at runtime. I generally opt for boot, then I have to reboot to get into my new generation. If I'm not sure that things are going to work out for me, or I don't feel like rebooting, I can try things by just saying build me a VM. And that command takes virtually no time. So what happens is, it'll build a tiny QEMU VM that is literally your system right now with whatever changes you've made if you'd like that. And what happens is, because it mounts in your Nix store from your system, it doesn't need to create a disk, it doesn't need to install anything. It's literally just an init that'll fire up the VM, and everything is there. Like I could run this on my laptop right now, and it'll probably take 5 seconds, and I'd have a running VM.
So what do you do about all the configuration of everything?
It comes into the VM.
From Well, like,
From my, so my system will effectively be cloned.
packages, right? But like, you can't just install HTTP and use it. So like, where does that live? Right, like it's usually in Etsy HTTP copy, right? So like, if you want to.
Right, but remember that all of these are just symlinks in a NixOS, right? Everything is a symlink. Like even your Etsy folder is just a bunch of symlinks into my Nix store. So by me mounting in the Nix store,
You version all those things the same as you would.
everything. So if you did a symlink count on my NixOS system right now, I don't know, you'd probably be close to 1 million. Because everything lives in Nix store and nowhere else. The entire rest of my system is just symlinks. That's it. And so when I say build me a VM, it'll do the same thing. It'll mount in the Nix store, build a crap ton of symlinks, and here's my VM ready to go. And that's why it takes no time for me to try things out. Right? If I want to change my system and I don't feel like ruining my actual system, I just make a VM with that configuration and see what happens. It's just that easy. And then if I'm happy with it, I say NixOS rebuild boot, and it will make that persistent to my actual machine. Yes?
So the config files all these applications need, where do they live? Or
Same thing. So what happens is, if you look at something like Docker here, Nix has something called a module system. So when I say virtualization Docker, there's a module behind that. And that module tells Docker how to behave, where its configurations files are, etc. So what ends up happening is these extra options, or just the general configuration for an application, is basically, sometimes we add custom patches to packages just to make them point at something else or make their configuration path configurable. A lot of packages you'll encounter have like a hard-coded Etsy, this is me, config.json or something.
So
And then
it's a little different than what you're used to on a Red Hat box.
absolutely. So you will still have that file, but the file is assembling into the Nix store, right? Does that make sense? Perfect.
Do your changes get clobbered ever then? Like if the Docker daemon.json or whatever, or say some other file, was just a symlink into the store, but you had changed it to add something, and then you do an upgrade, and now that symlink is putting it, and they upgraded, say, their configuration template or whatever.
Okay.
Will your new symlink now point at basically the template without any of your changes?
I'm not sure I
You're
follow.
talking about like if you're using Apache 2, you got the configuration options to change. You've edited it locally, they have a completely different.
That's what I'm implying.
Like you have to like.
So your configuration syntax would change or something? Is that what you're going
It's
after?
like migrate the config somehow.
In Arch Linux, you have this idea of pack news. So if like all packages know about what they expect, and
Right.
you had changed it, and like whatever, /etc/whatever. If you had changed it, and then the package manager recognizes that you did, and a new version of it is coming in, it won't clobber your changes. It'll just put the new version.
Oh, I see.
Pack new, and it'll be like, yo, you got to resolve this because there's like a merge conflict here.
I see what you're saying. That can't happen, and I'll tell you why.
Okay.
The files in your Nix store are read-only. You literally can't change it.
Right.
So, right? So that's your conflict. So
Only configure things in here.
you only ever configure everything in here.
So then you have.
So your Nginx or whatever.
All of the options. Too.
Yes.
Okay.
And you'll get errors when it does change.
Absolutely. So this is effectively an abstraction over the configuration that Docker expects. A lot of modules will have a variable called extra options, where you can then paste raw configuration syntax.
It doesn't solve that problem.
That problem is still on you, but the common configuration parameters will be solved, like by me just enabling things, or I don't know, if you pick what screen is your primary on an X11, that is just an abstraction inside Nix, and it'll be converted to whatever format X11 actually expects.
So where do you usually store your extra configuration then? If you've got like an actual system running, a lot of people use like Chef, Puppet, like whatever, to like have all their environment specific config when they boot up a new box. So
Right.
Apache being a good example, right? You you got to harden the Apache server, you got some custom config for your site.
Right.
Like where do people in NixOS keep that?
Okay, so when I said this is one file, I lied just a little bit. This one file has the ability to import other files. So I would have an Apache hardened.nix that I would import into my configuration, and now I have a hardened Apache on that system. So, and I can afterwards point people at my Git repo as well if you'd like to. I have things that are machine specific, then I have a common config, I actually have a hardened config that I can apply on top of the common stuff to do some kernel tweaks and such. And I effectively pull in a bunch of files, compose them with one another to arrive at what ends up being my configuration.nix. Does that answer the question? Okay.
I have a question.
Yes.
In the case of you providing extra options to a module,
Yep.
if you were to change the configs in that particular config file, does that imply that a new generation will be created? Or would that be like, those are your own configs?
No, so the moment you use extra options, it's all on you. None of the guarantees work anymore.
But you have to apply them with the new generation to have them take effect, right?
So I think what he's saying, correct me if I'm wrong, in this case I'm pointing at config file etc docker-daemon.json. Now if I went into this JSON file and just typed garbage in there, there's no way for Nix to know that.
Yeah.
Right?
Okay, so then
But if you use extra options and you tinker with those, you would have to do a new generation.
Absolutely. But if you have extra option that just points at a random file, you change that random file, there's no way for it to know.
Yeah.
So just to hit that home, if you went up into kernel sysctl, you changed 60 to 80, you then have to say Nix whatever, accept my new config.
Absolutely.
Okay.
Absolutely.
So changing that doesn't actually change anything.
No, so my configuration at the end of the day is just a file, right? I still need to apply that file for my system to
Which is a
change.
generation that you could then roll back.
Exactly. Exactly.
What if it's a binary file, like let's say an NVIDIA proprietary driver? Can you get it on that?
And NVIDIA,
Say I have a data center, a data science workstation.
yeah.
The open source ones aren't going to cut it. They need
Okay.
NVIDIA ones for that particular card. There's no source for it.
Right.
Or we don't have a package for it. How do I get it?
For that particular one, we actually do.
So you do.
So what happens is there is a parameter in this config where you can say allow unfree packages.
Okay.
So that in the Git repo, you will find quite a few packages that are unfree and not available by default because we try to keep that built from source mentality intact. In this case, with the NVIDIA driver, for example, I'm 99% sure that exists, where you can just say allow the unfree packages, and then you can pull it in like any other package as well.
But you still get a version, like,
Absolutely.
you still get a version jack binary blob.
Right.
Yes, effectively Nix then provides a wrapper around that binary blob because there's nothing we can do with that binary blob, or almost nothing anyways. So it'll provide a wrapper that does the versioning and the hashing, etc., to keep track of the package itself. Okay? I have no idea how I am on time. All right. We will not do the encores, but I can show it to people afterwards if you're interested. Okay? I'll just kind of finish up with this, which is we can take this idea of building your system from a single file and build on top of that and say, well, what if I want an entire cluster built from that one file? What if I want, things like Terraform kind of provide you with that idea, and there's a tool called NixOps which can do something very similar. So I can take my configuration from my laptop and I can say, well, I want the target to be VirtualBox, or I can change that to EC2, and I want to pull up 10 of them in Amazon. I give it a credential set, and that's it. It'll fire up the EC2s and 10 of them. And if I then say, well, maybe tomorrow I want to upgrade my entire cluster, I can do that just as easily as, if you've ever used Terraform, the idea is very much similar to that.
Can I do the intermediate step to generate the AMI and publish it?
generate the AMI and publish
You'll
it.
appreciate this. We don't just deploy AMIs. We deploy them to a sandbox, and then we validate them, make sure that they're secure before we publish them, before we allow EC2 instances to fire up.
So can you generate the virtual machine image?
Just the image.
Oh, I see. I see.
Someone's doing it because they're available. Like,
Yeah.
NixOS images are available.
Yes. Yes. I want to say yes. I have never done that.
Maybe by definition you have to.
Someone's doing it.
Something is doing it. Whether you can intercept them is the question, and I don't know the answer to that.
Because it sounded like you create it and you just push it up. I want the intermediate.
Yeah. I want to say yes, but I can't guarantee that because I've never done that.
I think with Amazon you have to be able to do
You
it.
have to be able to.
Because you have to point out an image, so there's no other way.
And push it to different regions. And,
Yeah, you could like
Right.
one region.
yeah.
Right. So similar to what a Terraform provider would do, there are NixOps modules that kind of take care of the the nitty-gritty that is specific to AWS, and I imagine that would be in there. All right. I can show you these slides, but I don't have time to talk about them. So basically what this comes down to is, and I kind of don't need time for questions, unless people have questions. Okay, let's do that first, because there were questions in between. You've kind of, go ahead.
So recently, and I only found out about the project itself when they released their 1.0, but GUIX, or however you want to pronounce that, came out with their
Yes.
1.0, and
Yes.
they're all like, oh yeah, we're reproducible too, but our configuration language is our own list. So do you have opinions on that versus NixOS?
Not really, because I've seen it, but I haven't used it. A lot of the ideas do sound similar, and I've only been the same as you. I've only been aware of it since the 1.0 came out. I do know one person at my company that has tried it out. I don't know why, but he decided to prefer Nix. That's all I can say about that. And this is one person's opinion, so.
Would you say there's overlap with Atomic OS and Fedora Atomic at all?
Yes, and Atomic OS, is that the Debian version of the same project?
Just like the general concept.
Yeah, so I know for a fact Red Hat and Fedora in turn and Debian also have some initiatives to provide reproducibility on a lot of their packages. They went the direction that I mentioned earlier, where they have a definition of reproducible that is not, it is bit reproducible. So you get a lot of the same stuff that you get from Nix, but they're not quite there. They're doing very good work though.
The concept is just container for everything, switching containers.
So I mean, that's the other question, is like, where do you see this versus a Docker container, right? Like what's the usage difference, right? Because most people are just going to make 20 Docker containers and push those up to ECS or EKS, right? Instead
Right.
of pushing 20 EC2 instances.
Yeah, I don't know that I
left server, right? Like most
Yeah.
people, like the modern architectures, or like that, most people are pushing the Docker bits.
For sure.
So like, how do you see this compared to that?
So Docker containers are in no way reproducible, first of all.
Well, they're not reproducible. They have a hash. You build with a hash, and then that hash doesn't.
You can roll back still.
I'll be talking about this tomorrow.
Right.
Okay.
All right.
Yeah, I
Well,
just wanted to.
I'll be there and discuss with you, but
I don't
yes.
particularly love the
Yeah.
way Docker works. That's why I'm like.
Right. I can take one more question and whatever. Fight.
Are you concerned about removing GitHub as a dependency for this?
Removing GitHub as the dependency. So the dependency is actually just any Git. GitHub is just a convenient way of doing it. I'm not super concerned, and if you're thinking what happened to Gentoo, then yes, the concern is there. Because things still have to go through, and I can tell you more about this after, things still have to go through Hydra, and things still have to have matching hashes, etc. I think it's not quite as easy to get away with, but the threat is certainly there.
So something with the FPFS might be good.
It might be. Okay, I gotta cut this off. Thank you everybody for coming.